Hi guys, sorry the boredom factor here perhaps, but it's math lesson time. I want to do a lesson in math. So here goes. How you guys doing? I want to discuss complex numbers or complex variables, sometimes called complex analysis. You have an x-axis and a y-axis. And the x-axis is x, the y-axis is I, y. I is I equals the square root of -1. It doesn't exist, but we just make it up like it as if it did. No number is if I is equal to the square root of -1, then I squared equals -1, and there's no such number. No number when squared gives you a negative number, but we just make it up and call it I for the purposes of analysis and systems engineering and all kinds of other things. So any point on this graph is this much x and then this much iy. So this could be, if this much is 1 and this much is 1, then this point would be 1 plus I, not times but plus 1 plus I, and so forth. This point here might be 1 minus I. This point might be -1 minus I. And this point could be -1 plus I. So it's like a coordinate, it's a two-dimensional number graph called it's called the Argand diagram. It's sometimes called the complex plane because the plane is a two-sided figure. And that's what it is. It's a complex plane, or Now I'm going to do some things here. Now let me erase this for a second. Now there's such a thing as Euler's formula, which says that e to the I theta equals cosine plus I. I did not make enough room, did I? Let's try that again. Okay, e to I theta equals cosine theta plus I sine theta. Now there's also z is a complex number, and z equals x plus I y. Z is any complex number. I want to do something with Euler's theorem here, or formula, I should say, which is right here. This formula right here: e to the I theta equals cosine theta plus I sine theta. If you have e to the I theta, cosine theta could be a value here, and I sine theta could be a value here. So it would be like this number right here, and the x part would be cosine theta, and the y part would be I sine theta. And what you have, let me erase some of this. You have two things here that are worth talking about. You have a trig identity that says that cosine squared theta plus sine squared theta equals 1. It's a trig identity. And for any angle theta, cosine squared theta plus sine squared theta equals 1. But you also have the Pythagorean theorem that says for any right triangle, a squared plus b squared equals c squared, or the shorter side of a right triangle plus the second shortest side of it, the shortest side of a right triangle squared plus the other side or longer side, or one side of a right triangle squared plus the other side of a right triangle squared is equal to the hypotenuse, the side that is opposite the angle. So if this is your angle, then this could be A, this could be B, and this could be C. A squared plus B squared equals C squared means you have a right triangle where C is the largest leg of the triangle because it's opposite the right angle. So what I'm going to do, I'm going to say therefore that this is for this point right here, if this is cosine, if this is cosine theta, because so I have z equals cosine. No, I have this e to the I theta equals cosine theta plus I sine theta. This point right here, if this part is cosine theta, and this part is sine theta, right here, that would give you cosine theta plus I sine theta, which is e to the I theta. Because of the right triangle formula, we can make a right triangle like this. And see, this is the right angle, 90-degree angle. If a squared plus b squared equals c squared, then that means that cosine theta, that means that this right here is, it means that this radius right here, I'm going to call this radius r. That's this radius right here. By the Pythagorean theorem, cosine squared theta plus sine squared theta equals r squared. Okay, whatever r turns out to be. But let's see what r is. According to this trigonometric formula, cosine squared theta plus sine squared theta equals 1. So we have cosine squared theta plus sine squared theta equals 1. That means that r is equal to 1. So we don't even have to call it r anymore. We can call this 1. So that's what we have. That is and now let's keep going here. I know this might be boring, but just bear with me. Let's erase all this. Just have the graph for a second. So I didn't mean to erase this. Cosine theta. So this is cosine theta. This is sine theta. This is 1. Okay, and therefore, if I want to make the r more than 1 or less than 1, then what I have to do is, I have e to the I theta equals cosine theta plus I sine theta, and this formula, it is also diagrammed on here by a circle, where right now the radius is 1, and for this is the e to the I theta is called polar coordinates. So if I have z equals e to the I theta, that is a polar representation of z, because z equals x plus I y. So what this means is, for any point on this, and so far we have a unit. This is called the unit circle. So this would be for the unit circle. Any point is defined by a radius, which in this case is 1, and an angle. So z equals e to the I theta. This is theta right here. This angle right here. This angle. Let me erase this. Okay, so far this is 1. This angle is theta. That angle right there. So for any point along the circle, I can denote with polar coordinates by this, because for whatever theta I have, that puts me at a different point around the circle, and the radius is 1, so it's called a unit circle. And there's only one more thing so if I want, and theta's in radians, which means that theta is the number of the number of radius values are made by the angle going counterclockwise starting here on the x-axis, and how long this whatever, like if the angle is right here, if that's the angle theta, I'm write a good theta here. Let me write that right. If this is theta, then however much this length is how many radians theta is. So let's make theta, just for fun, if there's such a thing in this. Let's make theta 9 degrees. Oh, that would be 9 degrees, but we don't say degrees, and we don't say 90. We say in radians, how many of these radians can be mapped out by this arc right here. That's that, and that would be the answer to how many radians this angle is. So since the circumference of the circle equals pi times the diameter of the circle, then the circumference of the circle equals 2 pi times the radius of the circle, because the diameter is twice the radius. If c, that means all around the circle is 2 pi, because that's how many of these go all the way around is 2 pi. Then how much is this much? Well, this much would be 2 pi over 4, because I'm going 1/4 the way around the circle, and that is equal to pi over 2. So what we know from that, is that this angle right here is pi over 2, not 90 degrees, but pi over 2 radians. Now here's a little thing. I want to do something here. I'm more than halfway through this. We're more than halfway through. So now we know this is pi over 2. I'll erase this right here. What would this value be? Well, we have that. Hope you guys can see this all this time. E to the I pi over 2, because that's now the angle, equals cosine pi over 2 plus I sine pi over 2. Cosine pi over 2 is 0. That goes to 0. Sine pi over 2 is 1. So therefore, this number, this e to the I pi over 2, is cosine theta, which is 0, plus I sine theta, which is I. And what's sine theta? What's sine of pi over 2? Well, the sine of pi over 2 is the y. Is the y is this height, the y value at pi over 2 at pi over 2. Yes, at pi over 2 radians. So that would be 1. Therefore, 1 times sine, since sine pi over 2. This is 1, and then I have cosine theta pi over 2 is 0 plus I sine pi over 2, but that's sine pi over 2 is just 1, so that equals I. So that means this number right here is I, but we already could tell that because the x is the real value, which is 0. The y is the imaginary number value, which in this case is 1 because we have a unit circle. So basically what I just proved, with taking all this out here, almost done here. We're getting close to the end here. What I just proved, let me just move my board, my mistake. What I just proved is that e to the I pi over 2, I'll write that a little better. E to the I pi over 2 equals I. That's what we just showed. Now we did some tricks with this. I'm going to say, what if I take the I power both sides? I have e to the I pi over 2 to the I, all of it to the I, equals I to the I. Okay? This is a pi over 2. I didn't write that very well. I have bad handwriting. Pi over 2, like that. But e to the I, pi over 2 to the I equals e to the I squared pi over 2. But I squared, but I squared equals -1. So that's equals e to the -1 times pi over 2, which is equal to e to the minus pi over 2. So, and that originally was what we said that was I to the I. So what we have is, from all that, we have that I to the I equals e to the minus pi over 2, which is really cool. And that's equal to 1 over the square root of e to the pi, which is a real number, which is funny. An imaginary number to an imaginary power is actually equal to a real number. So that's interesting. And one more thing. Now we're really almost done. What if I make theta equal to what we would normally call 180 degrees? Would that be all the way around? Theta would now be, since 90 degrees is pi over 2, then 180 degrees will be pi. So this angle of 180 degrees is really pi. Is this, plus you know that if the radius time around the whole circle is 2 pi, then the radius half around the circle is pi, because you know that circumference equals we know that circumference divided by diameter equals pi, but circumference divided by r equals 2 pi, because if r is half of d, if you make this half, it actually increases this one by 2. If c over r is equal to 2 pi, then this angle here is r is c over r is 2 pi. That would mean that this this r would be pi, because if the circumference divided by radius is 2 pi, so that means that circumference over this is half. 2 pi. Circumference over d is pi. Circumference over r. Circumference over r, you have that. 2 pi r. D is okay. Let's just really slow. D equals 2r, and that would be equal to pi. So I'm going to multiply both sides by r, and that would mean that. Let's see. Let me think. If this is a radius, and it takes 2 pi to go all the way around the circle, it would take pi to go around half the circle. So we know this angle is pi, because pi equals c over d, which means pi equals c over 2r, which means that if r that 2r pi equals c, r pi equals c, And what am I doing here? C. If r equals 1, which it is, then 2 pi equals c. But then this is half of c. That would mean that if 2 pi equals c, then pi equals c over 2. Wait, 2 pi equals, yeah, or the angle, I should say, not pi, but the angle. So this angle is circumference over divided, pi equals, yes, no, pi equals c over 2. Pi equals circumference over that, yes, because the radius is 1 here. Okay, so that, I'm just getting confused about simple little math here. I was trying to do something different, but let me just finish this. I got to finish my thought here. Radians is how much, so if circumference equals pi over d, and then if d is if d is 2r, then circumference equals pi over 2r. But if r equals 1, then c equals pi over 2. And the circumference, oh, I know what I'm doing wrong. I get it. Diameter. Okay. Yes, c equals pi over 2. For r is equal to 1 c. I know that a radian is this arc, and this arc, oh, I get it. Okay, I can do it like this. Here's what I'll do. I'll save it here. This is just basic math. This circumference from here to go around here is actually half of c. So we have and that's the angle. So theta equals 1/2 of c. 1/2 of the circumference is equal to the angle. But if the circumference is equal to circumference equals circumference equals, because I know the circumference equals pi. Okay, circumference, wait, yeah, half the circumference. So since pi equals c over 2r, then c equals 2r pi. And that's right. So theta equals 1/2 of c, but c is 2. But c is 2r pi. But 2 divided by 2 cancel each other out, so theta equals r times pi, but r is 1, so theta equals pi. That's the angle theta right here. Sorry that took me so long. I had to work that out though. Okay, we worked that out. So that means this angle, which gets called 180 degrees, is actually pi radians. So by our formula, e to the I pi equals cosine pi plus I sine pi. That's not a very good pi there. Cosine pi, and not a negative either. Okay. So, and that's for this, that's for this one right here. So if e to the I pi was cosine of pi. Cosine of pi is -1. Sine of pi is 0. So we have e to the I pi equals -1 plus 0. Because cosine pi is -1, and sine pi is 0. So we have, let's rewrite this up here. Let's rewrite this up here. If we have, I'm going to now erase this. We don't need this anymore. because we get a good vision of that anyway. If this is true, that means that e to the I pi equals e to the I pi plus 1 equals 0, because I just added 1 to both sides. So e to the I pi plus 1 equals 0. And that's called Euler's identity. E to the I pi plus 1 equals 0. That is Euler's identity. It's brilliant in math. It's got 0, it's got 1, it's got I, pi, e, it's got addition, it's got multiplication, it's got exponentiation. Love you guys. Peace. Rock and roll.